Welcome back to the Science Lab. So we're going to be doing a fairly simple demo experiment today to look at the idea of tectonic plate motion. It's going to be trying to mimic that a little bit. Guys.
That looks cool.
Yeah, it does look kind of cool, right? I'll explain what it is in just a second. Tectonic plates, right? They're the crusty things that move around on the surface of the Earth.
Made of graham crackers.
Made of graham crackers, as we know.
They're called graham.
What is below the graham cracker layer?
Peanut butter.
Right, the peanut butter layer. Okay. So the peanut butter layer, in reality, is called the mantle. And in case you're confused, we're referencing the last time I did an earth science experiment, which was a few weeks ago.
That's where peanut butter comes from.
Right, if you want to go check it out, we use graham crackers and peanut butter to model tectonic plate boundaries, okay? But today we're going to think a little bit bigger. We want to sort of think about how the tectonic plates over the whole Earth move and sort of what that means for continent setup and formation. So the layer below, the peanut butter layer, I should say, is technically called the mantle. And it's a layer of semi-viscous rock, okay? So it's rock that's so heated and so under pressure that it flows. And it doesn't flow quite as quickly as corn syrup, which I have here, but we're going to use corn syrup to mimic the flow. So, and just to kind of see just how slowly corn syrup actually does flow, I put red food coloring in this corn syrup about 2 hours ago, and it's still clear down at the bottom here. And that's just, again, corn syrup flows very slowly, and that's going to sort of help us here. So kind of gross, but Becca, would you mind just making a layer of corn syrup on the bottom of that pan for us there? Just, you got to probably squeeze out the whole thing. All right, so while Becca's doing that, we want to think a little bit about the continents of the Earth. I've got one right here. What continent is that, Nate?
North America.
Yeah, here, you take, let's label, but you take that one, and maybe I'll just put out a couple of these here. And I guess what I'd like to ask you, and Becca, I know you're working over there, but do the continents you see anywhere between the continents you're looking at, do you see a place where the continents kind of could come together almost like puzzle pieces?
Yeah, like South America and Africa.
Yeah, so the totally classic one is South America and Africa. So I'll kind of hold these up here. So here's South America, here's Africa, and you can see this very easily on a map if it's not very clear right here, and I can also try to hold it on a close-up camera here. Let's see if we can close up, maybe you can put there we go. Okay, guys, so maybe you can see South America and Africa kind of fit into each other perfectly right there, and the boundaries of my little cardstock continents are not perfect, but if they were, you can see South America really fits nicely into that. What is that? The Cape of Africa, Horn of Africa area. Oh no, the Horn of Africa's over here, over the other side. Never mind. But in any case,
we're just all agreeing.
Yeah, well, just say yes. But in any case, so if you look overall at the different continents, you start to see different areas where they could kind of match up almost like puzzle pieces. And sort of along those lines, I'm going to just turn on our Earth here. So what we're going to do here is mimic the Earth and its layers. The hot plate that I have down there below is going to be the core of the Earth, which because it's a ball of molten, well, it's a ball of actually solid nickel and iron. It's super hot, so it would be liquid on the surface of the Earth, but it's under so much pressure that it's actually a solid ball of metal. But it's super hot, and it is what is heating the mantle above it. Okay, and so it's heating it much in the way that this hot plate is heating the corn syrup in the pan. So we'll let that heat up for just a few minutes here. And while we do that, I just want to talk a little bit about convection. So the reason that the plates move as they do, and we're going to hopefully see that movement, is that there's something going on in the mantle called convection. Have you guys heard of this before? It's one of the ways that heat transfers.
I have.
What do you guys know about convection?
Does that have to do with a fault line?
Not exactly. No. So convection is just the idea. It's how heat moves through like a liquid body, let's say. So for example, convection occurs in the water pot on your stove when you boil water.
What about like a convection oven?
Convection oven is definitely okay. So convection oven, same kind of deal.
It's kind of really just how it moves.
Yeah. So we're gonna demo this really quickly. So what I have here is a little fire.
So cute.
So, well, actually, let's just take the fire away for 1 second. Let me put out the fire for just a minute. So, you guys are each going to be a cold water molecule, okay? There you
Cold
go.
water.
Cold water molecule. Take it.
right.
Okay, so you guys are cold water molecules, okay? And when water molecules are cold and they're in like a container, so let's say we're gonna put a pot on the stove, okay? And you guys are all in the pot. When water molecules are cold, they tend to sink low. Okay, so can you guys sink down to the bottom of the pot here? Maybe we'll call the bottom of the pot right here.
All right.
I don't know if you can get yours in front there, Jeff.
It's right in front of Becca's.
Anyway, so cold water molecules, they're going to be sort of low. The coldest water molecules should be at the lowest point in our pan, okay?
Okay.
But I'm going to start a fire underneath you guys, and that's going to start warming you guys up. And Jeff's got the idea, but as you guys warm, you should rise. And you should rise and rise and rise. And as you rise, you're getting warmer and warmer. And here, I'm going to change you guys out for red water molecules.
Oh.
Red now. Oh, thanks. Here, Jeff. You would be red too.
Awesome. I like that.
Okay, so now they're red water molecules, which represent the fact that these water molecules are hot. Let's say you get to the top. Now come up right about here. Let's say that's the top of the water. Okay, you guys have gotten as high as you can in terms of getting away from the heat at this point,
But we're
rising.
far away from the heat.
You're as far away. You're not quite as far away as the heat as you can get. And what's coming up below you guys? What's going to
Cold
be coming
water.
right behind you?
Warmer water.
Well,
Warm
yeah, water that's being other water
it's-
molecules that are
Right.
being warmed up,
Yeah.
right? And they're going to push you guys out of the way. And so you're going to get as far away from the heat as you can. So once you reach the surface of the water, you have nowhere left to move upward. Where can you move?
To the
the
side.
side.
That's right. So you would move out to the side. So let's just all move away from the center.
Real?
It's rocking both things. So, but no. Okay, so let's just stop right here. Okay, so the heated water molecules have moved away from the center of the pot to get as far from the heat as possible because they have more energy in them and they're rising. Okay, but now they're further from the heat source. So what happens to them?
They're
gonna
cooling
cool.
down.
They're gonna get colder. Okay, so switch out for
Oh,
blue water
cold
molecules.
again.
So as you guys are all the way up at the edges of the
Well-
pot, you get cold again, and what happens?
We start sinking.
Yes, you sink again. You would actually sink right back to the center, and then you would repeat the process, heat up again.
Boop, 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 getting warmer.
swap it out.
I'm hot now.
Okay, so maybe my little molecule demonstration is getting a little bit messy, but generally
We should
speaking,
have just worn costumes.
that you know what I was
think.
thinking about doing was having you. Actually, what I should have done is made you guys little flip molecules where you could have been like warm for a
flip over.
second and then cold for another second.
I see.
That's what I should have done was a warm cold flip, but
This might be a kind
Next
of a
time.
dumb
Next time,
question.
now you
but
know.
Is that when water boils?
Yeah.
Is that what happens? It like
yeah,
goes
Why it rolls.
That's
like that?
exactly right. So the reason that we have movement and these currents that are going on inside of the water is purely because you've got this convection current going. That's what it's called, is a convection current. Same thing is happening in a convection oven, but a convection oven, this is happening in air. So what I should say is that this happens in any fluid. Convection occurs in any fluid. So air being a fluid, water, other liquids being a fluid. So in a convection oven, right, you'd be heating from below, and you would get currents of air moving up and then to the side and down, up and then to the side and down and back to the center. And so that is really the kind of movement that we expect to get from convection.
Cool.
Is that those kind of circular movements. So inside the Earth, the core of the Earth is heating the mantle, and there are convection currents moving throughout the mantle. So we'll come back to that in just a second. Let's see. So, and this is going to be a little bit hard for us to demo. Hopefully we can get this with the side camera here, but can you guys help me? Can you guys set up the Earth as it's supposed to actually be? What is the
I
Earth?
got
supposed to be?
Antarctica.
Come on.
South
You guys are
Kidding.
you guys are
We got it.
teachers. You got this. All right, Africa, perfect. Australia down here. So hopefully you guys can see. I'll just sort of point out for folks at home. We got North America, South America. We got Asia. We got Africa. We have Australia. This area is also sometimes called Oceania, and then we have Antarctica down here below in the southern hemisphere.
Well, you
All right.
could argue that it's up there too. I'm kidding.
Actually, you can.
I mean, if it's round, right?
Yes, sure. It is still the South Pole, but
Sorry, I'm just being difficult.
given that we have convection currents in the mantle, guys, these continents are like plates that are sitting on top of the mantle. What do you think happens over time to these plates as they sit on top of the convecting mantle?
They crack.
Pushed around.
They move.
They definitely crack, they get pushed around, they move. That's exactly right. So there was a time, roughly 300 million years ago, that's very rough, but there was a time when all the continents were actually squished together into one single, what we call a supercontinent. Do you guys know the name of it? Oh, you
Pangea.
guys are so
Yeah.
good. So Pangea, and we can actually set up Pangea. Pangea was set up, oh, thanks so much. Pangea was set up with South America and
Right.
Africa stuck together, North America coming over Africa like this, Europe and Asia coming like this, and then, what was it, Antarctica like this, and Australia roughly like this. Also,
Or perhaps up there.
interestingly, Interestingly, the piece of continental crust that makes up India, I don't know if you guys can see, but that's India right there. That piece of continental crust was hooked on down here with the Antarctica, Africa, Australia bit.
So it
that's where the
shifted and went
Everest
connected to.
is right there.
Yeah, that's exactly right. And it shifted and moved apart. So what we're going to try to do, and I'm hoping looks like we're getting some heat here. So I'm hoping we should be
convection.
getting some convection currents. What I'd like you guys to do as best you can you try to transfer Pangea into the pan?
Easy.
Okay. Can we do it
I like
sideways?
that. Like that attitude, Nate.
Should we start with Europe?
Start with Europe.
Let's start with Europe over here.
Boom. And I would
then
say
go Africa,
however
yeah.
you guys can kind
Africa.
of get them in there,
Here?
we'll
Yeah.
call good.
In South America here.
It's like a puzzle. North
It
America.
is like a puzzle.
Oh, wow.
Where'd we say
Yep,
Antarctica? was?
Antarctica's down
here?
there. Yep, that's perfect. And then Australia goes here. Oh, God. And
Perfect.
it should go here. Okay, so what we should see over time is
Can we
God, this
move
pan.
this?
My pan is just a little bit too small here for my continents. Let's see if we can move
Oh,
it
I don't know if
forward.
that's helping the vision.
So, okay, so what you are seeing, what are you seeing?
You're seeing it kind of bubbling up in the
rising.
center, and it's pushing.
Africa's rising.
It's rising up, which is going to push it out.
Yeah, but should be pushing it out. You can see South America's also pushing it out. Hopefully, we will get some movement.
yeah,
It looks like we might not be getting heat through the pan all the way.
Maybe we should throw a little extra heat.
Yeah, sure. A little vapor fire into there.
Might help a little bit.
And a bit. Okay, so
Put it in the red molecules.
I think we are slowly seeing it now. Do you guys see South
Yeah.
America pushing it a little
Yes.
bit? We'll
Africa's
see that we get a
kinda-
little bit of corn syrup smoke, and just gonna turn this off just in case I don't want to set up the smoke.
Right.
Holy God. So let's just hope that nothing bad happens there. But what we can kind of see here, and it's not happening perfectly because my pan is a little bit small, but we can see that Africa, at least, which is right over our heating element, is pushing outward on the other plates and pushing them into the edges. Now, the pan is not like the Earth in terms of shape. How would the Earth be different?
Well,
So it's curved.
There's a sphere, right? And so
Yeah.
this heating element, what you have to imagine is the whole Earth would have to be wrapped around the heating element. And so it would be heating from all sides at once. And so that would keep currents going in all different directions. So you'd have some stuff moving away, some stuff being pushed together. And you would have, at any given moment, those currents can kind of shift and change, just like water boiling in your pan. Okay?
So Mount Everest forming where India is in Asia would probably be because it's pushing into it.
Yeah, that's
together.
exactly
Remember
right. I
those
don't
graham
know.
crackers?
We may be able to sort of see.
Make a little Everest.
Yes.
Go on.
So India would have spun up and pushed against
Right.
the Asian continent like that. Ow, that's so hot. And created mountains that pushed into the Asian continent. And that pushing of the Indian plate into the Asian plate is still occurring. So Mount Everest is
yeah.
actually still growing
Growing.
every year just by a small amount. This is in contrast to like the Rockies, for example, which are not growing anymore. And in fact, they're eroding. So we think of them as shrinking.
Oh, how do they know that the Rockies aren't growing? And
So we can measure. There's a few different ways that we can do it. First of all, we don't see the tectonic activity. Like there isn't good evidence that there is pushing coming directly at the side of the continental United States. But beyond that, we can measure now very accurately the heights of these different mountains, and we know that they're not getting any taller. And in fact, we're seeing plenty of erosion, and that these mountains are slowly getting shorter.
Wow.
Whereas we can actually measure. I think they say that the Himalayas grow at the rate of your fingernails, roughly.
Oh, wow. So somebody who climbed Everest back in like 1950, and they climbed it today.
That's right. They're like
They would have been-
centimeters below.
Wow. Oh, that's
The current people, so they
Yeah.
haven't really achieved on the same level.
Right.
Okay, well, on that note, we're going to jump back to the Homework Hotline studio. So thank you so much for joining us. If you want to try this at home, go for it, but get a bigger pan,
More corn syrup.
more corn syrup maybe.
More corn syrup.
But we will see you back in the Homework Hotline studio in just a minute.